Hi everyone. In this video, I'd like to talk a little bit about synchronous and asynchronous code. On the last video, I used the async await keywords on the FastAPI routes, and I didn't elaborate on it, what's asynchronous and why do we use that in programming. So for today's video, I'll just talk a little bit about this. Now, to better understand asynchronous programming, I'll have to explain to you what's concurrency and parallelism. So concurrency means that you work on two things at a time, but not simultaneously. So how would that look? For example, let's say you have two canvases and you want to create the portrait of another person. In a concurrent setting, it would look like something like this. So you'll have your canvas, your left and right canvases, and what you'll do is go to the first one, draw the face, go to the second one, draw the face, then add the eyes, the nose, and the mouth, the eyes, and the nose, and the mouth, and so on and so forth. So you are not working on them simultaneously, but you are working on them at the same time. Now, for parallelism, the way that it would work, you'll take your canvas, split it, let's say, into half. Oops, split it into half. And then with both of your hands, you'll work on it. So it would look something like this. So face, mouth, but again, it would be with both of your hands, not just one. So essentially, it means that you work, let's say, you're using multiple cores to resolve the same issue, for example, to work on the same task. Now, let's go back to our FastAPI example, and let's see asynchronous versus asynchronous context. Now, this is our server, and let's assume that this is our database. Oops, okay, not the best drawing, but you get the idea. And here we have the end user. Now, when the end user makes an HTTP request to our to-do app, let's say our application requires 20 milliseconds to process up to the point that it's going to use the database. Then it's going to take 100 milliseconds to send it to the database to do what it needs to do, and then the database to respond. But in general, this would go like 100 milliseconds, regardless of the operation that we want to have. And then our backend server will take an additional 20 milliseconds to respond to the user. Now, in a synchronous context, this will take a total of 140 milliseconds. Why? 20 milliseconds to receive it, 100 milliseconds to do the database, and 20 milliseconds to reply. Now, in a sync context, this will be exactly the same. Nothing will change. Now, if let's say we add a second user, and these guys make their request at the same time to the server, then in a synchronous context, I'll just move it a little bit back. Now for the first user, again, it's gonna take 140 milliseconds and 280 milliseconds for the second user, which 140 milliseconds, it's gonna be the await time of our application, because when we have two users and one instance of our application can only serve one customer at a time. So out of these 240 seconds, 140 milliseconds is to wait for user one to finish his request, and 140 milliseconds for the second user to process his request. So in total, it's going to be 280 milliseconds. Now, there's a better way to do that. And with that, we're going to use the async code. So I'll just move it like here, and I'll just move this a little bit. And here I'll just draw this thing, which I'm gonna call it event loop. By the way, this is an event loop, but it's called event loop, but it's not like an array, or you don't loop over it. It's a state machine, okay? Just to get that out of the way to eliminate any confusion. So in an async context, the way that our application will work is as follows. It's gonna still receive the request from the second user. It's gonna make 20 milliseconds. But when it's gonna call the database, the execution of the code responsible for that, it's gonna be added in the event loop. So here I'm gonna have db1, okay, db1. So here, this is a coroutine. Coroutines are special functions that can pause and resume the execution. So the way that it's going to play out is as follows. The first user is going to make the request, 20 milliseconds for our server to process it. It's going to add a new coroutine to the event loop. Again, it's going to take 100 milliseconds for our database to respond. And while our backend is adding the database operation in the event loop, it's going to be able to accept a second request. So now the request from the second user is going to be accepted. After 20 milliseconds, it's going to add it to the event loop with a new coroutine. The first coroutine will be resolved. It's going to answer back to user one. The second coroutine will be resolved, and it's going to answer back to user two. So in total, for user one, again, it's going to be the same. It's going to be 140 milliseconds. But for user two, it's going to be 160 milliseconds. Because by the time our server was, because by the time that the database was busy doing the read-write operations or whatever, our server was available to process a new request. So as you can see, there is no impact for the first user, but there's going to be a lot of improvement for the second user. So when we have a lot of HTTP requests, we want to process them concurrently with asynchronous context. Now, a good question would be, why not just use async code everywhere, right? Because it seems something that it's actually useful, and it is. The problem with async code is that this event loop, it's gonna work on a single core. Same core, everything will be on the same core. So if, let's say, you want to do heavy mathematical computations, do image processing, or any other process that normally your computer would use multiple cores to work on it with parallelism, then event loop is not going to be the way to go, because we could be using more resources, but we are not, because we are forcing the event loop. Because we're forcing, anyways, the async code on a context that it shouldn't. So I think that's what I wanted to say. To emphasize about this. There's definitely more to dive into for both asynchronous code and concurrency and parallelism. But to give you the reasoning why I was using the async await keywords, I think this is a good enough explanation. If you have more questions about this, let me down below in the comments, and I'll try to reply to you as soon as possible. Thank you, and I'll see you on the next one.